Okay, so on this number 3, I'm looking for the value or values of x that make the equation true. In other words, solve for x, right? So first thing, since this is an absolute value function, I need to make sure that this is isolated, right? So nothing should be outside of the absolute value bars on this side of the equals, right? So that means I'm gonna get rid of the -2 and this 2 that's being multiplied. So as we know, we always get rid of what's added or subtracted first. So add 2 on both sides. So that's gonna leave us with 2 absolute value for x minus 5 equals 6, and then divide by 2. So that's gonna be equal to 3. So let me write my cleaned up version of that absolute value equation. Absolute value of 4x minus 5 equals 6 divided by 2, that's 3. Right, so you always need to clean up your absolute value equation to where all you have on one side of the equals is the absolute value part. And once you get it down to this simplified form, this is the point where you have to split your equation into 2, right? It's like the BOGO of equations, 2 in 1. So you do 4x minus 5 equals 3, right? So you keep the same answer. And then 4x minus 5 equals -3. So a positive answer and a negative answer. And then we just solve each equation for x. Okay, so according to my solving, x equals 2 or x equals 1/2. So that would make the answer here B. Now let's double check on decimals. We're gonna graph this to see if it actually works out. So let me pull decimals up. Just a second. All right, so we're gonna type in the equation exactly like it appears. 2 absolute value of 4x minus 5. Get out of the absolute value. -2 equals 4. Right, so it crosses at 2. And if I just keep zooming in, I can see that it also crosses at 0.5, which is 1/2. So 1/2 and 2, which is what I got when I solved. So I know it's right. Next example. What value of x makes the equation true? Okay, same thing here. First thing I'm going to do is make sure that I isolate the absolute value. So add 2 on both sides. That would leave me with and then that 5 out front's being multiplied. So to undo it, I divide. $25 divided by 5 is 5. And so it's my cleaned up version of the absolute value equation. Absolute value of 4x minus 3 equals 5. Now this is a point where I can split it into 2 equations. 4x minus 3 equals 5, and 4x minus 3 equals negative 5. Solve each equation for x. All I'm doing is getting x by itself. So according to my solving, x equals 2 or x equals negative 1/2. And I can verify that if I just go to Desmos and I graph it. Actually, since I already have something here, I'm just going to change it. That's 4x minus 3 minus 2 equals 23. And as you can see, it crosses here at negative 0.5, which is negative 1/2. And over here it crosses at 2. So it matches what I got. So I know my answers are right. So then the multiple choice, the correct answer here would be C. Right, so even if it's in a different order, as long as the numbers are exactly the same, then that's your answer. Okay, so for number 5, this one is asking what value of x makes the equation true. So it's still an absolute value function. So the way we solve it is exactly the same. Okay, so let's start by isolating the absolute value. Right, over here I have to subtract the 4 from 5 because I can't subtract it from 2x. Those are not like terms. So that would leave me with the absolute value of 7 minus x. So my first equation should have been 7 minus x equals 2x plus 1. And the other one would have been 7 minus x equals negative parentheses 2x plus 1. Right? I gotta make sure the negative goes to both. All right, so let's do this again. If I add x to both sides, that'll leave me with 7 equals 3x plus 1. And to isolate x, subtract 1 on both sides, leaving us with 6 equals 3x. And then we divide by 3, 6 over 3 equals 2. So 2 equals x. So notice that that answer is here, but I don't want to get too ahead of myself. So I want to make sure I solve the other one. 7 minus x equals, that would be negative 2x minus 1. And here, let's see. I'm going to add 2x on both sides. So that would leave me 7 plus x equals -1. And finally subtract 7 on both sides. So x equals -8. Okay, so what's happening here, right? Because we know that when we solve an absolute value equation, we should usually end up with two answers. Okay. Now there is such a thing as a fake solution. Okay. It's actually the term for it is extraneous solutions. And what that means is that you can get an answer by going through the solving process manually, algebraically, and you'll get an answer, but if you plug it in, it doesn't actually make the equation true. Okay, so that means that all the algebra steps, everything we did algebraically is sound and it's correct, but it doesn't actually make the equation true. So let me show you what I mean. If I plug in 2 in place of x, right? So if I plug in 2, that would be 7 minus 2. So the absolute value of 7 minus 2 plus 4. And that should equal 2 times x. So 2 times 2 plus 5. All right. 7 minus 2 is 5. And the absolute value of 5 is 5. So that gives me 5 plus 4 equals, that would be 4 plus 5. And that gives me 9 equals 9. Sweet. So x equals 2 makes the equation true. So that's good because that's what a solution is supposed to do, right? It's supposed to make the equation true. So 2 is definitely a possibility. These two are gone because I didn't get that at all when I solved it, and I know I did it correctly. So when you plug in 2, it actually does make the equation true. So let me move this out of the way so I can now plug in the -8. Okay, so let's see. If I plug in -8 in place of x, that would give me 7 minus a -8 plus 4 equals 2 times -8 plus 5. All right, let me keep simplifying. A double negative makes a plus, so that's really going to be 7 plus 8. Like this. 7 plus 8 is 15. And the absolute value of 15 is 15. So this would technically be 15 plus 4 equals 2 times -8 is -16. And then plus 5. All right. So 15 plus 4, well, that's going to give me 19. Let me resize it so I have a little bit more room. If I add those two numbers, that gives me 19. And if I add -16 plus 5, that's going to give me -11. So that's false. That doesn't actually work. So even though I got this answer by solving correctly, algebraically, it doesn't actually make the equation true. So that means that x equals 8 is an extraneous solution. So that means a solution that doesn't really work. So it's not really part of my solution set. It doesn't actually make the equation true. So the only x value that actually makes the equation true is 2. So then that means that my answer has to be D. Okay, this is an extraneous solution. Doesn't actually make the equation true. So this here is the reason behind it, right? When you plug it back in, it doesn't actually work, but 2 does. However, you can quickly check this by just using decimals, okay? And when you plug it in decimals, it's only going to show you one x-intercept. So 7 minus x, get out, plus 4 equals 2x plus 5. Okay, so as you can see, it crosses at 2. Now, of course, you should always zoom out just to make sure that there's no other line there that you don't see. But see, no matter how far I zoom out, that's the only line that's graphed. So it only crosses at 2, but it doesn't cross at -8. Right, so that further supports the fact that -8 is not really a solution, okay? It works out algebraically, but it doesn't actually make the equation true. So basically, if the answer choices have 2 answers, then you know that they're both real solutions. And you saw when I graphed them, that it does cross at 2 places. But when the answer choices only have one value of x, then that means that one of them is a real solution and the other one is extraneous. So you can check by plugging it back in and see which one actually makes the equation true, or take the shortcut, just graph it on decimals and see which one works. See which one actually gives you an x-intercept. All right, let's do the last. So we have 2 more. What value of m makes the equation true? Okay, so we know we could go straight to decimals, graph it. The only thing you have to do when you put it in decimals is change the variable to x, because decimals will not work if you put m. So let me solve it first and then we can check. The absolute value is already isolated, so it's 2m plus 12. So there's nothing for me to move or clean up. So it means I can start solving already. I can split it and solve. So one equation will be 2m plus 12 equals 7m minus 3. So your first equation is always exactly the exact same thing without the absolute value symbols. And the other equation will be the 2m plus 12. And on this one, once again, because you have more than one term, you have to ensure that the negative goes to both of them. So use parentheses to remember to distribute it. So we'll get to that later. Let me solve this one first. Subtract 2m on both sides. I always move the smallest m, like I said earlier, so that it keeps the variable positive. So that's going to give me 12 equals 5m minus 3. Add 3 on both sides. So that'll be 15 equals 5m. So divide by 5. And 15 divided by 5 is 3. So 3 equals m. Okay, I could do a quick mental check. Let's see. 2 times 3 is 6. 6 plus 12 is 18. And the absolute value of 18 is 18. So that would give me 18 on the left. All right, 7 times 3 is 21. And 21 minus 3 is 18. Ooh, so my brain is telling me that 3 is probably the correct answer. But just to be safe, let me graph it on decimals. Absolute value, 2m plus 12. 2x plus 12, don't forget to change it to x, equals 7m minus 3, so 7x minus 3. And it shows that x equals 3. Uh-oh. Wait. So what did I do wrong? Let's see. Oh, wait, that's what I had. I don't know why in my mind I had to. Okay, so then that means that I don't really have to solve this other equation because I'm going to get an answer, but it's not going to be a real answer. It's going to be an extraneous solution. So this is it. Right, so I did that like quick mental check by plugging in. So I knew it worked, and then Decimal supported it, so I can stop working. I don't have to keep going. Now, if you do keep going, I'll show you. So as you can see, if you go through the algebraic process, you'll get an answer, but we know that this answer is extraneous. Okay, now if I didn't have decimals, I would have no choice but to solve both of them, plug them in, and see if it makes it true or false. But thanks to decimals, we don't really have to do that. Now, if I do my real quick mental check, 2 times -1 would be -2. Then -2 plus 12, that would 10. That would give me 10. So I would get 10 on the left-hand side. And then 7 times -1 is -7. Then -7 minus 3, that would give me -10. So this is false, right? So you could check it either way. Plug it in and see if it's true or false, or plug it in decimals. And I would assume you would probably rather do decimals than plugging it in. But the equations aren't too complicated, so it's pretty easy to do a quick mental check. Oh, and by the way, so if you were supposed to answer this, it would be a positive answer. It would be 3, and then you would bubble in the 3. You have to do this on ACP, so you have to learn to make sure to bubble it in right. All right, last one for sure. 3q plus 27 equals 6q minus 9. Absolute value is already isolated, so it's ready to be split, right? So one equation is going to be 3q plus 27 equals 6q minus 9. And then the other equation will be 3q plus 27 equals the negative answer. You got to make sure it goes to both. I'm running out of room here. All right, so let's solve the one on the left. Move the 3q. So I have 27 equals 3q minus 9. (27 plus 9), that's going to be 36. Oops. That was gone. And then divide by 3 on both sides. 36 divided by 3, that would be 12. All right. So since this is a free response question, we know that there's only one answer, so only one of the values will make it true. I'll graph it on decimals right now so we can see, but let me just solve this. Q. Try to stay consistent with my colors here. So I have 9Q equals 9 minus 27. That would be negative 18. Divide by 9. So Q equals negative 2. All right, so which one of these is the real solution? You can do a quick check by plugging in, but let me take the easy way out and just plug it in decimals. The reason I'm doing that, the numbers are a little bit larger, but it's doable. I just want to show you that decimals is usually the easiest. 2x plus 12 equals 7 and minus 3. 7x. And as you can see, the only line that crosses, so it only graphs one line, and that one line crosses at 3. Did I type something in wrong? Let me see. Wait, did I not? Okay, I don't know what happened. Oh, I forgot to scroll. I was still typing the previous problem. Oh goodness. 3x plus 27. And it's all right, notice that when I press enter, nothing shows up, but on the left-hand side, it shows a black, like a black circle with a line. That means it accepted the function. So the line is there, I just can't see it. So I'm going to zoom out. Oh, there it is. See, it graphs it in it graphs a black line, which matches the color that's over there next to where I typed it. And it looks like it crosses at 12. So that means that my answer is 12. And that makes Q equals negative 2 an extraneous solution. So it's not really a real answer. It doesn't actually work. So the only correct answer here is Q equals 12. All right, so all that is now summarized here. So this was the initial part from the first video that I skipped. So these are basically your steps for solving absolute value equations. If you're doing this by hand, which in my class I expect you to, steps 1 through 3 is basically how you solve it by hand, right? Step 4 is what you should do at the end, just to check that your answers are right, and to double check to see if there's any extraneous solutions. Here's a easy definition for extraneous solutions. I usually tell my students they're kind of like fake solutions. They're solutions that you get when you solve correctly, algebraically, but that answer doesn't actually make the equation true when you plug it back in. So you can choose either way. If you check by plugging in, you run the risk of possibly making a mathematical error, and you might think that your answer is extraneous when it's not. So I would suggest always graph it on decimals just to be safe. And of course, when you type it in, make sure you type it in right. So feel free to pause the video here, copy these notes down so if you find them useful. And if you feel like you didn't quite understand, feel free to watch the video again. Thank you guys for watching.